Okay, hello, dear guests. Today we will continue with conference, and my name is Andrija Bakoč, and I will be your moderator today. Once again, I would kindly ask you to keep the scheduled time for the presentation, which is 15 minutes, and after that everyone will have 5 minutes for question and discussion. Now I would like to invite our first presenter for today, our colleague from Croatia, Ana Čulić-Tanković. Okay.
Hello, good morning. Thank you for the kind presentation. I'm Ana Čulić-Tanković from Pula, actually working at the University of Rijeka, Faculty of Tourism and Hospitality Management. And I will shortly present you my paper, which is entitled Measuring the Newcomer's Perception of Virtual Servicescape for e-learning service. First of all, I would like just to point out that I am from the field of business. I am actually working at the Department of Marketing. So my point of view are the customers, especially the perception of the e-learning service. My agenda for today is just to briefly point out the literature review, then my methodology for this research, its results, and to conclude. Which was my first impression and my first important thing to present. The e-learning is a service. Maybe you, as informatics or technologies, you will present the e-learning as platform or system. I hope I haven't made some mistake. But what is important for me that the e-learning is a service. And I will take an exam from e-learning from the perspective of service marketing. The e-learning is a teaching tool which enriches the learning experience. In this way, we have to define what is service. What is a service? For Vargo at Altri, it's an application for competencies by one entity for the benefit of another. In this way, for the example of e-learning, these competencies are from the teacher for the benefit of the students, participants. This definition implies two important things. First of all, the collaboration, which for the e-learning is very important, and the service of application of knowledge. In this way, e-learning must and need to apply the SD logic, service domain logic, which implies that knowledge and skills are the key resources for competitive advantages. Starting from this and knowing that we have to apply a service domain logic for a better understanding of e-learning, my point of view and my focus of interest in this research was the newcomer. The new users of e-learning service and their perception of it. Why? Because the successful using of e-learning depends on its continued use. Use that is continuous. And now just briefly about the virtual servicescape, which is my focal point of this research. First of all, the servicescape, it's a term that derives from landscape and implies the environment, that the total configuration of physical elements where the service is offered. For the virtual and e-commerce business and everything that is digital and virtual, there is this trespassing from physical elements to virtual one. So for digital marketing, we are talking about virtual servicescape that is an online environment. The virtual servicescape is extensively researched for the e-commerce and business and online purchase and something like that. And it's this kind of relationship from virtual services that affect trust, repurchase intention, loyalty, cognitive and affective responses are already proved. But there is no research where the perception of virtual servicescape is proven for or investigated for e-learning services. That's why my research has this research question: how do newcomers perceive the virtual servicescape on the e-learning platform? That's why my methodology was based on a survey. It's a quantitative approach, and invitations were sent by email containing an URL leading the survey. Responses were confidential, and the sample was picked up from new users of the Lumen Cabinet e-learning platform on different academic years. Maybe it's important also to underline that we had at my university, at my faculty, also one new course for teachers who was also newcomers at the e-learning platform. This sample and these questionnaires were collected throughout August and September, and the response rate was 29%. This questionnaire was designed by 6 closed questions for demographic data and 42 items on 7-point Likert scale, from 1 strongly disagree and 7 strongly agree. The scale for virtual servicescape perception was adapted from Harris and Good and contained it was a third-order model and contained, the pointer isn't working, but it contained aesthetic appeal and 2 factors, aesthetic appeal and layout and functionality. The aesthetic appeal had already 3, thank you. Okay. 3 dimensions: visual appeal, originality, okay, thank you. Visual appeal, originality of design, visual appeal 5 items, originality of design 7 items, and entertainment value 5 items. A layout and functionality had 4 dimensions: usability 11 items, relevance of information 5 items, customization, personalization 7 items, and interactivity 5 items. The survey was then elaborated by IPN SPSS statistics and Smart PLS for the PLSM method. What was my results? First of all, starting from the sample characteristics, predominantly the participant and learners were at the 85%. Why? Because there was a 50% of teachers, as I previously stated. The majority were young, 22 and 30 years, and with the higher master education qualification, spending weekly 1 to 4 hours on the e-learning platform. I used the formative model because the indicators cause the construct, and I will prove it on my model. And but starting from this original scale with these 42 items, 10 of them, 10 indicators, were eliminated because of the outer loadings smaller and minor of 0.4. Then I had to perform all the measures from internal consistent reliability and convergent validity. As you can see here, for the 2nd and 3rd order formative indicators, the Cronbach alpha is a measure of 0.7 for all these indicators, and CR is a major of 0.7, and the average variable extension was major of 0.5. So in this way, I can state that my formative measurement construct possess satisfactory level of internal consistent reliability and convergent validity. After that, I will just shortly present you, I don't know how you see this model, is a third order model. The first order model have all significant effect on the second order model, except for this one, originality of design. This is aesthetic appeal as the second order indicators. And the visual appealing and entertain value has a significant effect, but the originality of design has not. On the other side, layout and functionality has all first order constructs have a statistical significant effect on layout and functionality, and the second order to the third order aesthetic appeal and layout and functionality has both significant effect, statistically significant effect, but the layout and functionality has a major effect than aesthetic appeal. In this way, I can conclude my research and my presentation, stating that the e-learning platform has a satisfactory level of layout and functionality on this Lumen current platform, but the originality of design is uncreative, and so there is no statistical significance. There is a positive impact of likability on the size and the enthusiasm of entertainers for offered services. So the users consider their e-learning offers high usability functions. On the other side, there is a need to improve the design and aesthetic appeal side of this e-learning platform for newcomers. So this is my presentation. I'm thanking you for your attention. I hope I was in my time. And if you have some question, I will very likely to answer them. Thank you. No questions? No? Okay. Thank you. Okay, thank you.
Thank you, Anna. It was a great presentation. And our next speaker is Igor Jugo, also from Croatia. You have the floor.
Dobar dan svima. Ja sam Igor. Sorry, I'm going to try it in English. So my name is Igor from the Department of Informatics, University of Rijeka, Croatia. So this is this presentation presents one part of a rather complex system we developed during my PhD studies. So I'll try to give you a few introductory slides to give you context about the whole system and what the goal of the system was, and then I'll try to focus on this specific part that that is presented today. So we during the last 3 or 4 years we developed an intelligent tutoring system and used it as an auxiliary tool during our lectures on 3 or 4 courses. So this tutoring system is developed in a way that leads the student from more complex units of knowledge to some simple ones, or the other way around. Depending, the student has complete freedom to choose his or her learning path. So in general, this research belongs to the field of educational data mining. And when I read a lot of research in this field, I discovered that the whole EDM community put forth some research objectives for the whole community to solve. So, and I was especially interested in these two underlined objectives, which said that EDM tools have to be designed to be easier for educators, which don't have to be experts in data mining. And also that the data mining tools have to be integrated into the e-learning environment. So this was very interesting for me because I read a lot of literature on this field, and I saw that a lot of these works are very disengaged, because people usually collect some data during a semester, and then they have to export the data, then they do some data mining on the data they acquired. And when they get some results, they try to input it into a learning system or a learning process. And then they see what's going on with the next generation of students which used the same system, which is powered by the data mining model acquired from the students from the previous academic year. So I saw a really big technical and temporal gap between these processes. It also involved a lot of experts. So I thought I could do it better. So I developed an integrated platform that connected our existing intelligent tutoring system to data mining tools. So the idea was I can talk to data mining tools directly from my intelligent tutoring system, or to simplify, I can do data mining from a web browser by clicking a button. There was absolutely no technical skills involved. You just click a button, you get the results on your web browser. So that was the idea. And the integrator part is very important for the next pieces of the puzzle, which are sequential pattern mining and clustering of students. So, but the overall goal was to make our intelligent tutoring system better by providing hints to students. And when I say hints, it's just a suggestion at the top of the screen that says, you have selected Unit A, maybe you should learn Unit B before this one. Or when he or she is finished with learning a Unit A, then you get the information, now you should go learn Unit C. Okay? And these terms, prefix and suffix, will come into play a few slides from now. So, but where do the hints come from? The hints come from sequential pattern mining of student paths. So what is a path? A path is just, like I said before, the integrator system logs absolutely all interaction, all data from students while they're using the tutoring system. So we have a lot of data. And also we collect these paths, which are units visited while learning in our system. But not all paths are the same. So we developed an algorithm that validates the paths. So not when a student starts to learn a unit, he or she have to answer questions. And it can answer correctly or incorrectly. When he or she answers all the questions correctly, it's an optimal path. When it answers all of them incorrectly, it's a zero utility path. So then we performed sequential pattern mining on these paths. But the problem is, if you use all the paths from all the students, then you can provide the same hints to all students, but not all students are the same. And also, we discovered that we will never get the best paths created by the best students. We will never get them out as frequent patterns because they drown in a much larger number of low-quality paths. So we decided to perform clustering of students based on the way they use the system, and then do sequential pattern mining for each cluster separately. This way we can get the best students and analyze the best paths created by them, and find out what was the the highest utility frequent paths of the best students, or the slowest, the struggling students, or average students. But I'm not going to talk about this part a lot. I'm just going to say that we developed this thing, and it works simultaneously with sequential pattern mining module of the system. So just a few information about this thing. So we create a number of clustering models, then we calculate the silhouette statistic value for each clustering model and select the one with the highest value, which is here. And then we have a method that evaluates each cluster in terms of which students do they represent. This is important for a tutoring system, for a tutoring model, because we want to provide hints for this group of clusters from the discovered parts of this cluster and one cluster above it. So the idea is there's no point of giving hints from the best group of students to this group. So we wanted to make the system pedagogically flexible. So this group of students receives hints from the paths discovered in this group or one group above. This group gets hints from the paths discovered in this group or one group above, graded above. Yeah? Okay. So how are the paths created in our system? The system is called DITUS, which is simply a Department of Informatics tutoring system. And so our system has a hierarchy of knowledge units. You can see it here on the left. This is a very, very simplified domain model. So let's say it has only 5 knowledge units. So if the student starts to learn the unit 1, it's presented with learning materials, and after he or she has read the materials, she has to answer one question. If it answers it correctly, then the knowledge level for this unit 1 is upgraded. And also, the student is presented with 2 initial questions, which are questions that do not require memory of certain important facts about a unit, but are just to test if the student understands the underlying concepts, which are 2 and 3. And if the student answers all of these questions correctly, this learning activity is finished. So he or she can go and learn another unit. So, but not all students answer the questions correctly, so you get a longer and longer paths. And these paths are become the database for sequential pattern mining. So this is the outline of the algorithm. These 3 bullets here are displayed on the next 3 slides. So this is just a pseudocode of our algorithm. I'll try to keep it simple. So for each cluster, and for each member of the cluster, we convert their paths, calculate the path efficiency, and add them to a larger cluster sequence database. Then write it to a file, invoke the SPMF tool via the integrator model, and then we get the high utility frequent patterns out. So this is the first bullet. How do we convert the paths? So these are all paths created by one student during a number of sessions in which the student used the system. And for example, we are now interested we do this for each unit in the system. So we are now interested in unit 189, which is a database ID of the knowledge unit. And we analyze all the parts, all the units visited before this unit, and all the units visited after he or she has learned unit 189. And we transform them into a number of prefix and suffix paths, which are used then to provide hints on what should be learned before or what to learn after a unit has been learned. So this slide is the next phase, which is path efficiency calculation. So I'll try not to get into too much detail, but all in all, if the student answers everything correctly, then it's a higher utility path. If it keeps answering everything incorrectly, then this path will be much longer and it has a lower utility. He or she has not learned anything. Maybe they just were guessing answer to questions. So we tested this on our tutoring system on 2 domains with about 70 students, 35 of them in the control group, 35 of them in the test group. They had 4 or 7 days to complete this knowledge domain in our system. So the important thing is that this system feeds itself. So when we log the data that is created by students while they are using the system, we are continually performing clustering and then sequential pattern mining on the data that we logged. So every 400 new interactions, we do another clustering and sequential pattern mining process to get new and better hints. So for the duration of this first part, for the domain that's called web technologies, we did 9 such runs, and we continually updated the clustering model and the sequential pattern mining database. And for domain number 2, which is design patterns in web application development, we did this 13 times. So the system is fully integrated and there is no involvement of teachers. How are hints displayed to students? Well, like I said, they just see the text about the user interface, which says maybe you should learn unit B before A, or maybe you should learn C after B. So something about the results. So this is for each. This is our database of learning interactions. It keeps growing. And then this is the time for the 4 days that they had to complete. This is the number of clusters we had in the clustering model at the moment that we did sequential pattern mining. This is the number of paths discovered, of frequent high utility paths discovered by the sequential pattern mining algorithm. It also keeps growing. And but usually they're well balanced. So we had a bit more of prefix paths than suffix paths, and you see here that we covered the whole domain actually rather late in the duration of the experiment. But our goal is not to get hints for every unit in the knowledge domain. The most important thing is to get hints when to learn a unit that is problematic to most students. Of course, not all students follow these suggestions. So you can see here that the number of hints that are actually clicked or followed is rather low and remains rather low. So this is a visualization of all the data displayed in the previous 2 tables. You can see that the number of frequent paths that discovered is rising. Actually, I'm not sure what happened at this point, but I have to analyze the data. I'm guessing that there was a lot of same paths created, because the students were probably guessing the answers and trying the same unit again and again and again and again. So you get a very low number of discovered frequent paths. I'm guessing it was. But you see here that the usage of hints remains rather low. They just ignore them a lot. But all in all, when we analyzed the data from the two groups, we discovered that in a way we have acquired our objective, and we have lowered the number of learning interactions in the test group, so they finished quicker, and they also had needed less time to do it. So this is a visualization of their advancement through the knowledge domain. So we put this red line here because these are the number of interactions most students should finish by then. So when analyzing this data, we actually saw that the students in the test group, there were more students that finished by this ideal limit of interactions that was needed to complete the knowledge domain. So there was a lot more students in this group. But these curves, learning curves, are actually very interesting because you can see how fast the students are advancing through the content. And here you can see some very struggling students that are using the system in a rather bad way. And you can see some cheating students that are trying to cheat the system because they know all the answers, they acquire the answers from other students. So you can see that their curve is practically vertical, which is not really possible. Yeah, so the system is developed and it's currently used by our students. Like I said, its name is Datus, and it's available at datus.uniri.hr. Okay, that's it for me. Thank you.
Thank you for Igor. Our next presenter is Ljubiša Jovev from Mirvas International from Serbia. Okay. Treba će vam internet, tako? To je tu. Ok, to je novi prozor. Spustit ćemo se ovako. Ovdje je prezentacija. Što uđe prvu prezentaciju ili će to je s menijom stavljeno.
Hello, good morning from my side. In this presentation, I will talk about one practical implementation of e-learning system. The topic is an e-learning system based on Odoo system, Odoo platform. And this is next. Okay. Okay. What we talk about in this paper, we are talking about some process of implementation of the e-learning platform for purpose of implementation of e-learning platform for one Erasmus Plus project, which name is part-time and short cycle education project in Serbia. And one of the delivery of this project is a proposal for e-learning platform for online education in these two segments of education. And I will talk about how we go through process of LMS selection and some criteria which includes process and decision for LMS. And then I switch to introduce you with some basic characteristics of Odoo platform. And after that, I will talk about some aspect of e-learning architecture we implemented. And finally, I will show you one demo, live demo of implementation of this platform. Okay, I will note some basic facts about ELMS. Probably all of us know what this term means. Learning management system is a very popular and well-known term, but many authors has a different feeling. What does mean if e-learning? It is very very confusing term. Some people expect one thing from LMS, some other people expect some other things. And this is very difficult to make the border between some different components of e-learning process. Today, you can find very big offering on the market for ELMS systems, and to choose the right LMS system is not easy task. But for some educational institution, and the selecting of the right e-learning platform is crucial significance to answer for the following questions. The main question is, what are the real chance for the application in the real learning, real learning process? Selection criterion must be give right answer for the following criteria. The first criteria when implementing some LMS is the time required for implementation. Second is it is possible to adapt to the specific needs of the institution. And third is how reliable and secure this implementation. And fourth is a group of criteria about functionality. And the traditional approach in selection of the LMS is to check what functionality is implemented in some ELMS system. When we are talking about functional features in affecting in the selection of LMS, we select about 30 different criteria, and criteria in this criteria is listed here, and we don't have time to discuss each of them, but I know, or I believe that all of you have some impression what some of these criteria means. based on this functional features and all others, other selection criteria, we decide to implement pilot project for this e-learning platform based on some open source platform, which name is Odoo. Let me to note you that on the today we have three big group of ELMS systems. One ELMS systems group is so-called proprietary systems. Second is the open source group of e-learning platforms, and third is new approach, combination of cloud-based tools integrated for e-learning purposes. Each of these groups has different advantages and disadvantages, but we analyzing all aspects of the project, decide to build a new platform based on one open platform, and this platform is Odoo. Odoo is very new open source project, but what is the main characteristics of this platform? This platform is generally developed for ERP purposes, not for e-learning purposes. That is a very specific and interesting approach. Why this? We decide in learning process, not just ELMS is involved in this process, but in the all process of the one education institution is LMS and ERP and business functionalities is tightly integrated, need to be integrated. In traditional approach, institutions use many systems to satisfy this e-learning process. One system for e-learning and another system for ERP of institution. This needs to have two different platforms and many technical problems in integration, and especially in maintenance. We decide to try to integrate all this functionality in one system. Only one, just all needs of the one education institution to integrate in just one system, and we conclude that Odoo is the best platform for this. As I said, this is open source, this is mature system, and very, very important characteristic is because this is very scalable and adoptable system. On this picture, you can see three main components of Odoo platform. This is, first of all, the database is PostgreSQL database server, and Odoo application server based on the Python is the main component of this, and the user interface is implemented as a special web client. one important characteristic because of Odoo, because this is initially started, this is European, very big European open source project, started from very young people from Belgium, from Brussels, and last year the European Commission selected Odoo as a very good company project and gives a recommendation for European and European investor to put big money in development of this platform. And today, Odoo is selected as the number three open source ERP system in the world. Based on in this picture is presented how we implement what this e-learning architecture, on what is the vision of this future e-learning platform. This e-learning platform has three main components. One component is this Odoo platform and itself. Second platform is backend of e-learning platform, and third is the student portal. The student portal is the typical web application for students using this in platform, and this student portal is for registered and unregistered visitors, and backend platform is for professor, authors, and administrating people from institutions. In this picture, you will see how looks like this student portal, and after some minutes I will show in real how this home page looks like and what elements in this page are. In this picture is presented concept of the messaging system implemented in this in this e-learning platform. This concept is the channel concept, which includes video channel for distribution, static document channel for delivering of the content prepared before developing, and the dynamic HTML content prepared by a special authoring tool development by Metropolitan University called by MDTA authoring tool. In backend, I implemented many functionalities. These functionalities is grouped in three main groups of functionalities. First of group is the course content, second group is tests, and third group is surveys. And in this picture, you see how looks like interface for preparing of one course. And now I will try to switch to demo site. I hope it will work. No. Oh yes. No. Okay, thank you. Okay. This is login page, but this okay. So before. Okay. This is home page, proposed home page. This is not official. And in this home page, the students can see some marketing information about short cycle courses. And after that, some news. And so that is very classical home page as all other web pages. But what is in this link, we have page, dynamic page with available courses, and visitors can see some available courses and some short information about these courses, and how many you can see how many students on this course, who is the author and instructor, and the name. But after that, you can see detailed page about this course, short description of this course, and after that you can see this 5 group of information about these courses. This is syllabus of these courses, and tests, and links to some social pages for discussion, for chats, and for communication with other students and instructors. When we click in this, we can see subtitles, and we have in this some information for other type of content implemented in this course. If click here, we can see some information, some content prepared as PDF document, and students can go to this. Okay. some content can be prepared as the video. No. Oh, sorry. How to switch? Okay. What is about time is I think. Just to show you how looks like backend. In backend we have this and what is interesting, this is course, okay, this is page for preparing for one course. We have short and long description for this. We have information about students. We have information about topics, about instructors, marketing information about other linked courses, categorization of these courses, surveys, and links on preparing for forum and blog for interactive communication of the group. And in this part, we have interface for preparing the tests. This is many other parameters we have to choose when we create test, and what is the limit time for preparing test, what is the way of navigation, what is the obligation for some answers and so on, but this is all detail. Okay, I hope you see some important features of this implementation, and I will finish my presentation in this moment. And if you have some questions, please. Yes.
I think you maybe take the question.
Mm-hmm.
You said that Odoo is emphasis of training.
Yes.
So, what is your e-learning part? That is module for test or what? You use what for e-learning? Some kind of module for Odoo?
Yes. Odoo is very, very open and modular platform, and primary Odoo is developed for the ERP purposes, but today Odoo is not just platform for ERP. Odoo is the set of business suite tools. Okay, for these purposes, we find that it's very good, very easy to develop a special model for e-learning purposes and just upgrade existing modules for website building, development, and user registration and so on, and develop special model for LMS and for test at the moment. In the future, we will develop some specific models for e-learning purposes, but we have at the moment we have connection to the all available commercial models for ERP purposes, as payment and bookkeeping and emailing and any other functions available in each ERP system. Yeah. Yes, it is possible. Yes, absolutely, it is possible because Odoo has API based on the XML ERPC, and the connection can be very easy made. The main issue is how to connect users of the e-learning system and users of the other part of the information system in educational institution. No. Yes.
What is the main difference between Moodle, learning management system, and two-folder? In other words, what is the things unique about Moodle compared to the Moodle?
To the Moodle?
Yes.
Okay, you know, Moodle is the well-known e-learning system, LMS system, specially developed for the e-learning purposes. And Odoo is not that's platform. If you need to integrate with Moodle with other part of the information system of the institution, you will probably have big issues to do that. That is the key difference. In our approach, the e-learning is just one of 10,000 models available today in the Odoo platform. What is the next very important things is because the future development of the e-learning system will be in the area of the analytics, learning analytics. Learning analytics is most important part for implementation of the personal, adaptive personal learning system. And we strongly believe that we can use very easy some additional models development already for artificial intelligence, especially for deep learning, developing the Python platform, and we can easily integrate this part of the open source development and integrate with this system, and finally we believe that we can very good implementation. Thank you.
Thank you very much. Now we will have a little break, 15 minutes for coffee, and then we will have an online presentation by Skype. Okay, thank you.
So my name is Alexander. I'm an assistant professor at the University of Faculty of Computer Science. Before you have a slightly shortly video for us from my regular website is personalizovanom, and my metode, my type was famously who is system at the Faculty of Engineering. So our paper is about, as you can see, this technology enabled to take paper in university or in higher education institutions. We always must address change the source of quality of the and also the name of technology in trust. Why is this important? Because always students expect a relevant and engaged learning experience. So therefore we use sport blended learning and flipped classroom. If you have below the text on the picture, which explains how the form looks like, and therefore is an approach that integrates the method of face-to-face online experience worldwide educational goals. So, what is the concept that we use in faculties? It's a form of flipped classroom where educational techniques consists from two parts. The first part is interactive group learning activities, as you can see on the picture, and direct computer-based individual instructions outside the classroom. The text will be given several views from our concept of activities at the university, and one of the concepts that we use at our universities are web-based tools, where we use Moodle, and with this web-based tool, we can increase the student opportunities. Other opportunities for students, they always can be regularly tested on the assigned weeks and within the use of competencies, and just assessing them to assess them between each other. So in our case, you will see it in a short bit. We do some quizzes to encourage to do it until you get it right, not just to assess them. We can use it like a self-assessment tool between each other. Our case study, we selected a subject mathematics or computer science subject, some literature, and the research we conducted at the university, it was observed two study years. You can see 2015, 2016, and the study 2016. We worked with around 600 students, Faculty of Medical Sciences at our university, of which 300 students attended informatics course for academic 2015 and 2016, and 300 academic 2016 and 2017. Two concepts used in these lectures. First academic year for 2016, we used regular old-fashioned way of teaching through our presentations and regular classes. And the second sample assessed student academic year 2016 and 2017, we used a different approach to combining the classical methods of lectures throughout presentation, using web technologies as an integral which besides presentations and standard forms of electronic testing, we use past activities as questionnaires, discussion groups, blog, video presentation. As one from activities, students in the academic year 2016-17 conducted several activities and acting their privileges of creating for themselves activities to be the creators of discussions, forms of voting, work activities online. The results were conducted throughout our center of e-learning. The results were given in the next slide, but these are the final results. Dramatically visible growing, achieving after completing all course activities. The class from 2015-16 have overall average of 48 points out of 100 marks, and with each of the fifth class from class 2016-2017 have had overall average about 61, 15 points out of 100. In the next slide are given graphics from the reports of statistics of the school system. And your right side is on figure 1, given the course of these students. I'm looking for the guide for how with the orange line are given students real activities, which hit is around 600. 600 hits by students, or 600 activities by students in the year 15-16. And here are the given only students' use of the work in 2015-2016. With using of the flipped classroom, the results were different. In the next year, the students' activities and hits by in the books, there were around 21,703. So it's a very big step in the activities conducted by students. And the results, as you can see, are about 50% greater than the year before. Here are the tables of activities by month. In the class 2015-16, the biggest students and student records were before finishing the student semester. And in 2016-17 student year, you can see in the last 3 months of the semester, activities were even greater than the max value of year 2016-17. You see that they are not even bigger than 50% by numbers. So, as a conclusion, by using this methodology and technique, we suggest that in order to ensure bigger, better progress in future research on the flipped classroom, we should employ controlled studies that effectively examine student performance throughout the semester, not only once the semester. We think that the difference between grades and students' results from interest in discussion to use more and more in the higher education classroom. And as you can see, as an illustration that we are guided by it. Five teachers is already thinking, and university is using a kind of a flipped platform. So question and more question of are you ready for flipping your class? So thank you again for listening to our presentation. If you have some questions, really go.
Thank you very much. Do we have some questions? No, thank you very much. Okay, we have one question for you. Okay, wait a moment. To ask how
projects in the area of e-learning.
Yes, you can talk to yes, we already have.
If you are involved, could you just quickly say us what are you doing?
I'm sorry?
If you are involved in any projects in the area of e-learning.
Yes, we are involved at the moment in two Erasmus projects.
Okay.
With open educational resources and connected in different areas. One is in the classroom of high schools, and another is vocational education marketing for agriculture. Developing open educational resources for agriculture.
Okay, that's excellent. We hope next year you will send a paper again and come personally to be here in Belgrade. Thank you very much.
Thank you. Question?
No, we don't have any more questions. Thank you once more and see you. Okay. Goodbye. Okay, we continue with our presentation. Next presenter is Marko Tanić. Okay.
Hello everyone. Today I'm going to present my work introducing 360-degree virtual reality into game dev education at Belgrade Metropolitan University. The goal of this work was to pave way for virtual reality, to introduce the virtual reality into game development education at our university. And we have decided to go with it by adapting an already existing flight simulator that was developed earlier also by our students, and introduce 360-degree stereoscopic viewer to it. So many of you have already tried during the break this simulator, but if anyone else wants to have a go and look at it, it's here set up, so feel free to stop by and try it out. So the primary goal was introducing new trends at Belgrade Metropolitan University at game dev studies, but also we had to take into consideration that many of the students don't have much money, that they have very limited budgets, and virtual reality equipment can be very expensive. So another goal of this project was to find the most low-cost solution to enable students to actually buy needed equipment. So now let's just put a quick overview on what virtual reality is. Virtual reality, the most broad definition I found was that VR is representing illusions of physical 3D reality by the means of computer input, output, and additional hardware. That's pretty broad definition, and depending on the level of immersion into the virtual world that the VR system intends to accomplish, there can be various very specialized VR devices like head trackers, hand trackers, and many other which can get really expensive. But the most popular and most often associated with VR are so-called VR headsets. And those are devices that combine stereoscopic viewing with head tracking. So here on these pictures you see two examples. One is on the left is Oculus Rift, and one on the right is smartphone, which is encased in stereoscopic viewer, essentially transforming a smartphone into a virtual reality headset. I'll just take a moment to explain a little bit how these headsets work. I mean, I suppose many of you already are familiar with it, but just a quick retrospective on that. So the stereoscopic viewing means that we render separate images for each eye, and so that the user looking at it can get perception of depth, because the pictures are slightly different and they're analogous to what human eyes normally see when we look outside. Also, head tracking means that we actually track the position and the rotation of the player's head, and based on that info, we render the appropriate part of the virtual world that the user is looking at. So in combination with the total enclosing of players' eyes, virtual reality headsets actually help player to immerse, to have an illusion that he really is in that virtual world. I mentioned a moment ago a smartphone as a stereoscopic device, and that was made possible with devices like this. This is a stereoscopic viewer, Google Cardboard. Actually, this is not the original Google Cardboard, but a copy of it, and it's enough easy to make so that people who don't want to buy it can just take the cardboard and cut out the appropriate shape. So it's really, really cheap, low cost, and it really enabled us to achieve that goal of making a low-cost solution. As I mentioned before, we have taken a already existing, already implemented flight simulator that our students implemented last year, I think, and we added this virtual reality headset to it. The flight simulator represents a project that was completed by multiple students and as a collaborative project, and parts of the simulator were individual project assignments for those students. And the simulator, the environment in which the simulation takes place is a model of Vršac airfield. Vršac is a town in Serbia where there is a pilot academy, and this is used for teaching pilots there. I mean, the plane Cessna 172, not our simulator, but maybe one day. So now we have added this stereoscopic viewer to make this project to qualify as virtual reality, and that meant porting that simulator that was implemented for PC initially to Android, and everything went well until we put the Android phone into this Google Cardboard, and then we realized that essentially we didn't have a way to fly the aeroplane because we have no longer the keyboard input that we would have on the PC. So we had to re-implement the simulator as a multi-module system where one module would run on the PC and the other module would run on Android phone, and that other module would also have stereoscopic renderer. Let's just get a little bit deeper into implementation details. This chart on the right side represents the architecture of this system. We have a PC which acts as a server for this configuration, And we have Android smartphone as clients, and they are connected with Wi-Fi. And they're synchronizing their states over Wi-Fi because they're essentially two independent applications running on two independent machines. The simulator was implemented with Unity 3D with free version, so that's also another way of how we accomplished our goal of making this low cost, because Unity 3D free is really free. I mean, you can use it freely for educational or commercial purposes. Also, for the 3D models, other tools were used, also their free versions. As I said, we're using Google Cardboard, which is essentially, I bought this one for about €5. And if you don't want to give even that much, I mean, you can, as I said, download the blueprint for this and cut it out of cardboard yourself. So that's also another way how we made this solution low cost. The synchronization over the network is implemented using Unity 3D's multiplayer system. So that's a system that was intended by Unity to be used by multiplayer games, but we took advantage of that system and implemented this multi-module simulator. Unity calls that system high-level networking API. So more implementation details. Server, as I've said, this is a server-client architecture where PC serves, actually the module running on PC serves as a server. And there are all the calculations for flight parameters, airplane position, airplane speed, and other parts of mathematical model are calculated. And the client has the Android phone. The module Android phone has stereo rendering role and head tracking, so that it can be viewed. You can view the simulation from there. So in the end, the reception among students was great. Many of the students took part in implementing this project, and valuable knowledge was acquired. For example, we had problems with the focal lengths, with properly focusing the virtual content, so we had to explore and solve those kind of problems. Also, we made some presentations for students in their classes, in their game development classes for other students who didn't take part of the project. And, you know, the effect was amazing. I mean, everybody just swarmed up to the simulator and wanted to try it. I mean, as similar as what happened during the break here. So, in the end, we can say that we have really pushed forward the game development education of Metropolitan University. That would be it. Do you have any questions? Or does anybody else want to try out the simulator? Come on. Okay. Well, thank you for your attention.
incorporate into a standard education in Serbia and maybe in other countries. What was motivation for this article is that students and pupils now are using smartphones and using iPads every day for mostly, unfortunately, for social networking, for playing games and things like that. And as a consequence, they are used to interactivity and some kind of dynamic approach to systems. But problem is that material for study is not presented in this way, and it is mostly static. And this should be changed, and we will see how this can be accomplished at the example of subject of geography and elementary school. We will see how interactivity with map elements and coordinates can improve understanding of material, and how it should be incorporated in the e-learning system, which is not the situation at this moment. And as the result, specific need for new types of question emerged. This was the motivation for this research. There is a wide range of e-learning platform, and students are used to using it, but it doesn't change much, and many different subjects are presented in the same way, and the material
become monotonous and they lose interest in it. So two directions in improving of e-learning platforms should be in the terms of changing design and new functionality with specific approach to the different subjects. Also, mainly in this e-learning platform, we see multi-choice questions, which doesn't make students be exploratory and seek for knowledge just using those kind of questions. We are analyzing the specificity of subject geography in elementary school, because in elementary school, when we start at the 5th grade, many facts are explained using maps, cartogram, etc. And they're usually on a paper, and there is not interactivity with map, which should be the case, because it should be easier for them to understand the material that is very complex to them. And they are expecting the higher level of interactivity, and this kind of learning systems does not exist at this moment. When we look at the e-learning system, this is not like overview of all learning system. We're just thinking about the questions and testing the student knowledge, and we can divide them into 3 basic categories: knowledge test, ability test, and personal test. Maybe some psychometrician wouldn't agree on these categories, but what we need to focus on is knowledge tests that can be normative and criteria tests. Normative tests are not very interesting, because the success of those kind of tests is based on success comparing to others that did the test at the same time. For different criteria, tests are tests that measure knowledge based on some criteria that are previously previously created. And for examination of knowledge and teaching efficiency, criteria tests are used, and this way the students are examined of what they learned while studying the specific subjects. Why we want e-learning system? There are many games and also websites that offer this kind of interactivity, but they are not incorporated in e-learning systems, and we want to have advantage of them. The advantages are feedback on which parts of material are difficult. Then student can self-test them to see how they master material. Possibility of remote testing via internet, instantly results of testing, automatic time limitation. Those are some of advantages of e-learning system, and why we want to incorporate this kind of interactivity in them. As I said, e-learning system does not cover specialties of subjects in the way of presenting them differently, because it is necessary to improve learning and teaching processes. All of you know Moodle or Oracle e-learning, LMS is Sakai also. They're basically using static material, and they have some multimedia content, like playing some movies or something like that, but not in a part of testing and when the questions are given. So this needs to be changed for learning to be more attractive and more efficient. Why is geography interesting? It is compulsory in all European countries, and it has been studied for at least 3 to 5 years. And also in the Republic of Serbia, it is part of final exam at the end of elementary education, and it's very, very important for this material to be learned and adopted. For children, when they start with this subject, it is very abstract to them and very hard. We will see why. And it's hard for them to adopt. What is also interesting, that a National Education Council decided of Serbia on having standards for the end of education, what level of knowledge pupils should achieve. And they defined 3 levels of achievements: basic, intermediate, and advanced. They accept that basic level of knowledge, more than 80% of students achieve, while intermediate level is above 50%, which is really high percentage. And it will be convenient if we would have an e-learning system that would allow teachers to be able to create this kind of teaching material, and in accordance with these prescribed levels of achievement. On the basic level, as I said, it is very hard for them because it's abstract. Some of goals defined for them is to represent the Earth's surface, to read geographical and other elements of maps. In the intermediate level, they should be able to position and to point the special elements on the geographical maps. The most important is orientation on the map, like knowledge of terms of latitude and longitude, position of object, as I said, calculating distance between objects using the map scales, and possibility for students to interact with the maps should be implemented and is very important. Position of map elements. On the left side, you see this is one web application that is developed by my colleague, who is co-author of this article, and but it's not incorporated into some e-learning system, and it helps to position map element defined based on the latitude and longitude, and when you click on the mouse, you get some feedback, and you see if you got it right or wrong. And what is most important is that teacher can explain them and advise what should they do in order to get a correct answer. So interactive, this is one example of interaction. Interactivity should be enabled also with some different elements like parts of the globe. Another example is map scale. For them to be able to see maps on different scales, and based on that to calculate differences between distance between some geographical elements. This is also part of this web application that is already developed. Also other interactivities like selecting borders of states, locations of the states, mountains, and other geographical elements should be also very convenient to have implemented in some system. So there, as I said, exist specialized software solutions, some website and some games are already developed, but they are not incorporated into e-learning system and lack benefits such as centralized entry, administrative tools, and I also earlier said what benefits offers us e-learning systems. So what should we do? We should develop some additional add-ons, some additional software that can be easily implemented in existing e-learning system, and to be enabled to do quality testing of students, as well as increased quality of teaching. So as all of us know that it should be improved, and it should be, the e-learning system should be developed more, then we are not using it the efficient, and we should concentrate on the specificity of individual subject and decide what kind of interactivity is necessary and is good to have in order to help pupils and students to understand material, study material better. And that is basically conclusion. And do you have any questions? Thank you.
Thank you, Professor Ignjatović, for this great presentation. Now I would like to invite Mirjana Devetaković to present her paper.
vidim to, pošto nemam više. Hello. Da. Aha, tu je. A menjanje slajdova, izvinite. Aha. Neće. Mogu odavde. Ali htjela bi da se vratim sada. Aha, vidim. Evo ga, sad radi. Ne, dobro mi je odavde. Hello everyone. Thanks for being with us this afternoon already. My name is Mirjana Devetaković. I teach at the Faculty of Architecture, University of Belgrade, and will present a paper called A Critical Analysis of a Decade of Using the Moodle Platform in Architectural Education at our faculty, Faculty of Architecture, Belgrade University. I have structured my presentation on this way. I will give a short introduction, then we'll talk about the e-learning support that we had before establishing a Moodle platform. Then I will explain how we actually introduced the Moodle, give you an overview of courses in last 10 years, then give you a systematization of types of courses regarding using the Moodle, and additionally will mention some additional programming features that we made. And of course, I will conclude the presentation. As for introduction, my faculty is actually the oldest institution of that kind in the region, and we celebrate 170 years of architectural education this year. Why is this important? Because we constantly improving teaching methodology according, of course, the technology that changes. About the e-learning support before the Moodle, I had chance to teach in Auckland, New Zealand, in the year 2000, and in the institution Unitec, where I was teaching, we had established a Blackboard system, which was in that time very, very expensive and still is, and available to all teachers in that institutions. When I came back to Serbia, I was looking for the similar system at Belgrade University, but it was impossible to find such system, and it was impossible to
asked university to install, to buy Blackboard because it was too expensive for our university. So I tried Blackboard as a free trial course that could last 90 days. 90 days, it was not entirely enough for to cover one semester of our teaching. So the Blackboard as a free trial course was not a good solution. Then we discovered a content-based system called ArchNet, dedicated to all architects, architecture students and teachers interested in Islamic architecture, sitting at MIT in Boston, and funded by Aga Khan Trust for Culture. And it was open for all the students around the world. In this system, they had, it wasn't a learning environment, but they had work groups that could be used as learning environment. So about 4 years, we used ArchNet for our blended teaching, predominantly using forums. And after that, when ArchNet was reorganized, we had actually to make an in-house programmed virtual learning environment, and that learning environment was in our website, together with our website. How we introduced the Moodle. In the year 2008-2009, we started a strategic cooperation with the Computing Center of Belgrade University. Why we call it strategic cooperation? Because we decided to install a Moodle platform, but not only for our faculty. Okay, dobro mi je. But for whole academic network of Serbia. And that was our great achievement. Yesterday we heard that University of Jordan also skipped to Moodle predominantly because Moodle is free of charge and open system. Moodle actually functionally met our requirements of blended learning. That was obvious. It was already used in many academic institutions. That was important to us to persuade that it is suitable for us. It was free to download and install. Already successfully used by medical faculty of Belgrade University, which was also important to us. And in that time existed a wide community of users of Moodle. So any question that we might have, for any question that we might have, it was possible to find an answer among the users of Moodle. The advantages of setting Moodle platform to service or computing center of the University of Belgrade, that was again one of the advantages to have centralized platform because of our availability to all members of Serbian academic community. That was one good thing. Then centralized server space and maintenance. That was second. Regular updates to new versions of software. That was third, and supported by introductory trainings. It was second. Fourth good thing about the Moodle. And this is how it looks, the Moodle portal looks today. It is used by many faculties and all universities of Serbia. Now, an overview of active courses in Moodle in our institution. We started in the year 2008-2009, but immediately when we started, one of our colleagues asked us to open category 2007-2008 and put materials from last year to the Moodle platform. So practically our start is 2007-2008, and number of courses quickly increased. First year we had 2 courses, then 7, then 18, 11, 17, 19, 13, 11, and 6. And you will see that the number of courses increased in these years and then started to decrease, which we are not quite sure why. What's the reason? In our paper, in our analysis, you will have to see the difference between total number of courses per year and number of courses where a student had an active role, which is better use of e-learning system. Now I made a little systematization of courses and divided them in 2 groups. Courses distributing teaching materials, that means just delivering information, and courses including student activities. In the group of courses that just distributed teaching materials, I made this systematization. The course is distributing lecture presentations week by week, which is the most frequent. Then distributing initial course materials, for example, for studio projects, and distributing information on the course progress for workshops and studio projects. In the second group of courses, including student activities, we made this structuring, student activities based on discussion forums, student activities based on assignment submissions, and student activities based on tests. And I actually have chosen several examples of, this is example of student post in discussion forum. Our students communicate with visual materials, and the fact that Moodle forum allows publishing visual materials was important to us. So this is how it looks like when students communicate by forum. This is an example of the course where my colleague Tatjana Mrđenović just followed the course, her workshop, in different visual materials. This is long thread, I just gave a fragment. And this is an example of Moodle support to the studio project, which is the most complex actually to follow, because the studio project normally goes on in the common space, and this space we had to transpose into virtual environment. So this is one example of that. During our use of Moodle platform, we had additional requirements from the basic Moodle. So we programmed, I put here three examples of things. One was a system of alternative forums, similar to one that we had in our in-house programmed virtual environment. The second was a real-time chat window. We needed the impression of virtual presence of our students in the virtual studio. And finally, we programmed a striped virtual exhibition, which is on the picture. As for conclusion, after a couple of years of using various e-learning systems, Faculty of Architecture got a support from Belgrade University Computing Center, which established a centralized Moodle-based system available to entire network of Serbian state academic institutions. During the recent 10 years of using the Moodle-based system, a number of supported courses varied from 2 to 18 per school year. The virtual environment have been used for both distribution of course materials and interaction with students. The most efficient Moodle module for interaction with students in architectural education is Simple Forum, through which the students could participate in a virtual dialogue and publish and exchange various types of visual materials, CAD drawings, PDF documents, etc. Initiatives for using the virtual environment still come from the teaching team, and the use of e-learning is not required by school management. So it relies on the enthusiasm of teachers still. In the last 2 years, the use of Moodle systems started to decrease, and the reasons might include the fact that maintaining a virtual environment requires certain additional time and effort. So it is time-consuming activity. The fact that students are more oriented towards social networks and prefer applications available on their mobile devices. And finally, integration of virtual learning environments and social media could challenge architectural education in the next decade. Using mobile devices instead of computers might require rethinking of teaching methodology, leaving behind some routines and introducing new ones that need to be developed and tested further. Question? No, at our, this table. Are we talking of this table? Yeah. Okay. 19 from our faculty. I'm not quite sure now, because we are not editors anymore of whole. In first years, every faculty, at the very beginning here, every faculty gave 1 or 2 courses just to try. Teaching staff wanted to try the system. And after that, in that time, we edited the platform, whole platform. But after that time, Computing Center of Belgrade University employed 1 person to be editor and to care exclusively on the Moodle platform for whole academic, Serbian academic network. Sorry. Well, I can talk about my faculty. In this time when the number increased to 18, it was I call that the Tom Sawyer effect. Someone heard that something is good about using virtual environments, and then they wanted to try in their own manner to use it, but after that, I think that realized that it is more time that requires certain serious time to maintain good virtual environment, and they just gave up of that. Online learning method, no. In the meantime, we had one Erasmus project, and within that Erasmus project, we had specially programmed environment for e-learning. Why? Because e-learning permits cooperation among distant countries, which is, again, very important in architecture, despite the fact that we need face-to-face teaching in majority of our time. But if we would like to enlarge that scope, that space of intervention, and cooperate internationally, we need to develop methodology of working with virtual environments. So, voluntary. It is voluntary, yes. Totally, yes, and not recognized as an additional workload. So it is. It's not important whether you. Well, it depends of school management, of course, and of politics of school. At the moment, no plans for mandatory. Yes. For the faculty of structural engineering, they use because at the very beginning of our activity in Moodle setting, we organized trainings for different faculties, and one of the trainings was for the faculty of civil engineering. And since that time they use, I don't know how many courses actually per year they provide in e-learning, but they do. Regarding faculty of electronics, I'm not. Our colleague is here. Maybe she can tell us. Yes. I'm director of the computing center of University of Belgrade, Mr. Gain, certainly teaches using Moodle, but it is voluntary also. It is not mandatory like at the Metropolitan University. when I make trainings, I don't teach e-learning anymore, but when I used to teach colleagues, I was showing my experiences, and my experience is the most using forums, because in our education, discussion forum is something that really works. Why? Because students put their visual materials, and that serves like a virtual exhibition. So one student, when seeing someone else's works that might be better than his works, he is more motivated to make better, to remake his work. So no, I don't teach them just to put paper into PDF and hang in Moodle. But for majority of tutors, that's the first idea, actually. So we cannot do anything with that. I had another question from. Do you think about whole Moodle for whole academic network of Serbia, or just for our faculty? No, not. We have one interesting experience with our colleagues that put their materials, PDFs of presentations, teach 1 year, or let the students 1.5 years have access to the content, and then delete the content. So yesterday we heard the presentation about learning objects, open learning objects, and our colleagues are still not prepared to let their presentations forever to sit in. Okay, thank you very much.
Okay, thank you for great presentation. And please welcome to our next presenter, also our conference coordinator, Slobodan Jovanović.
Show from beginning. Show presented. Ne, mora prezentar bio da se sam se. Možete na stranici. Aha, vaš, okay.
So again, hello everybody. I'm the co-author of this paper. First author is Nikola Dimitrijević. He is from Niš, and in the moment he is ill, so I will be presenting this paper. Nikola Dimitrijević, during the last couple of years, was working on developing software for learning of programming languages, especially for learning of Java, and he developed a system which has some very good characteristics compared to the other systems in the market. So in this paper, I will firstly describe the couple of systems which are available on the market, and then I will quickly describe our system which we developed here in this university, and which we plan to develop more during next couple of years. So as you can see, the title of the paper is Analysis and Improvements of Computer Programming e-learning Systems based on a Learn by Coding approach. First question could be, what is the need for such systems? One of the main reasons for using these systems is that many young beginners in the area of learning of programming languages had a lot of difficulties. Typically, teachers or instructors are not around, so using some software, especially automatic software, which enables totally automatic learning of programming languages are very useful. So in this paper, firstly, we analyzed some systems which are frequently used on many universities, and then described our solution. Basically, those systems for using for your learning programming languages could be divided in two groups. One group is a group of systems where you can learn theory and practical exercises, and it is supposed that you are starting from scratch, basically that you know any knowledge on that programming language. So that's one group. And in that group, for example, belongs a system called Code Academy, which is very popular and used all around the world. So we analyzed this system and described main advantages and disadvantages of that system. Another group of systems is a group where it is supposed that you have some basic knowledge of programming languages, but you want to learn more to improve your knowledge. And one such example is a system called Coding Bot. Both systems, which I mentioned here, are used for Java and Python, and especially Code Academy is even used for some other programming languages. So in this paper, firstly, we analyze those systems on the market, available on the market, and then in short term, also describe a system which was developed here at this university. We can say that in our solution, solution that was produced by our colleague Nikola Dimitrievich from Niš. Good characteristics of both groups of systems are combined, and even some new options are introduced, which I will describe later. So first, I just want to quickly describe the system I firstly mentioned is called Code Academy system. So it belongs to the first group of systems where you are starting from zero, and you are supposed basically that you know even basic knowledge of that programming language. So you are learning in parallel theory on one side, and on the other side you also doing some practical exercises. So it is used for learning of Java, Python, JavaScript, Ruby, etc., and some other languages. What is the principle of the process of learning here is simply that the whole material is divided in sections, and so the order of those sections is specified in advance, and you go section by section and learn. First you learn theory, then after that you learn practical examples, but you learn the best way to learn practical examples, of course, by doing by yourself, or in other words, to code by yourself. One of good characteristics of this system, Code Academy system, is rich graphical user interface, because it enables both using learning theory and learning practical exercises. It's necessary its graphical user interface to be quite complex, and it has a whole lot of options which are listed here, you can see. It includes learning of theory, then of course executing some practical examples, but what is very interesting also, that includes forum, so users of this system can exchange their experiences. So that's a good thing about this system. And also very good thing is that if you have problems, the system provides you with some hints, with some suggestions. And here you can see graphical user interface as an illustration, and as I said, it's more complex compared to the other group of systems, because simply, for example, here you are supposed to learn both theory and practical examples, even forum and some other things. So if we want to summarize good things about this system, one thing that you can start from zero, so you can learn both theory and practical examples, rich graphical user interface, and it's quite popular because it is adapted to be used for many different languages. But there are some important disadvantages. First, there is no any personalization. That's one thing that today we can consider as a big disadvantage. And also, you cannot extend the repertoire and the list of problems you have in the system. System is quite not flexible, quite fixed. You have a list of problems which you can do, but you cannot include some new problems which you think that will be useful. And that's the disadvantage of this system. But on the other hand, it's something that it is good about another system. The system called Coding But, its main advantage is exactly that you can extend a number of practical examples. Even you can use not English language you can use if it's used in Serbia, for example, you can use Serbian language. So coding bots, as I said, the representative of the other group of systems where you are supposed to know basic things. You don't need to learn theory again, but simply doing practical exercises. As a result of that concept, of course, graphical user interface is quite simpler compared to the previous system. But again, great advantage is that you can, it's flexible, much more flexible than the previous one. You can extend number of exercises. A similar thing with the previous system is that whole process is divided in sections. So whole material is divided in sections, and you go section by section and learn programming. As I said before, graphical user interface is quite simpler, significantly simpler than the graphical user interface on Code Academy system. Here you can see the illustration of that graphical user interface. And a couple of things more about this system. It has a section which can be used by teacher just to observe, just to supervise what's happening with the students. That's something that is not included in the Code Academy system. And as I mentioned before, which is something very important, that in every section you can include by yourself. You can include more practical exercises. But on the other hand, something that we did in the system here, developed here at this university, there is no possibility of extending the number of sections. So in the system developed here, also it's possible to increase number of sections. So this paper, as I said before, have two purposes. First one, to analyze existing solutions in the market, and on the other hand, just quickly to explain our system. What we can say, our system is more friendly, more comprehensive, and more flexible, simply because on one hand, we combine good characteristics of both systems. That's one thing. And the second thing, we included some new options which we observed that they are not present in both systems. For example, it's possible to include video materials. It's possible to increase number of sections, etc., etc. And graphical user interface is quite comprehensive, quite complex. This is the illustration of the graphical user interface of our system called Java Online Editor. And now we can summarize this paper. So we have two basic purposes in this paper. First, to analyze systems for automatic and interactive e-learning of programming languages. And we described two main groups which are used in that area. And on the other hand, some work of our young colleague, Nikola Dimitrievich, we presented the system he developed and which can be developed more here in this university. Thank you. Questions and comments? I don't have it. Nicola promised to provide some video materials, but unfortunately he is ill. He has some problems with his throat. And, but anyone who is interested more in details of this system absolutely can contact Nicola. He will provide much more details about the system. He can send you video materials and other things, and the results of using this system. Yes, that's one of good things about this system. It is easily to produce. For example, you produce initially one course, then it's easily to modify it, to extend it, to make it shorter or anything you want, and to produce whole series of courses. And that's important for our university. As you know, we have a whole series of courses which are all Java related. So this characteristic is very useful and very good, and it's available in the system. Yeah, you mean Java object oriented. You can put anything you want in the moment. Of course, I think because Java is oriented to object oriented language, I cannot imagine that there is no something about classes and such things. Yes, I know for that software developed by Nebojša. Of course, it could be some communication and some support between those two systems. As I said, at our university, we are Java oriented. Yes, we learn Java and do it in many courses. Also, we do C++ and C#. Scripting languages we do, but in much smaller scale, you know. So in the moment, this system is not used for scripting languages, but it can be done easily. Okay, that's it. Thank you very much.
Okay. Thank you to Professor Jovanović. And he was the last speaker for today and for this conference. Thanks for all presenters. Now I would like to invite our university president for closing remarks. It's finished. He was last speaker.
Okay. I think that we all enjoyed these 2 days in a way. It was a relatively small conference this year. Somehow we had less papers, but even less presenters because some of authors didn't show up. But we hope that for next year we'll increase the number of both papers and presenters. But it doesn't reduce the quality. Some of papers are very good one and very significant. So we are going to continue working on that. But as I said at the beginning, as this conference is very specific conference, very focused on one narrow area, it's normal that you cannot expand a huge number of participants. And the other reason why is this happening is that we exaggerate with evaluating only papers shown presented on journals. So some people are avoiding conferences because of this, and especially in Serbia, because the ministry is providing more points, much more points if you publish in a journal. That's normal, but on the other hand, if we focus only on journals, we lose interactivity among our authors. We don't meet, we don't discuss. For instance, we had very pleasant discussions with colleagues from Jordan. We expect next year to see more people from Jordan, also from Romania, from Temișoara. Probably we initiate some collaboration works and so on. If we just publish in journals, we cannot meet, we cannot discuss, and we lose some values of this communication. So that's why we keep going, organizing such conferences. We have 3 conferences a year. 2 weeks from now, we have the conference related to information security. It's a very important aspect of information systems and technologies. And next May, we have another conference in the area of business and management. So we think that such conferences are very necessary just because we have to talk, we have to meet, we can to learn from each other, to discuss. And this is something that is necessary. We advocate using of e-learning, but e-learning is not something that is just one direction. We want collaboration among students. And believe me, on our forums, we discuss much more using e-learning system than we normally discuss in classrooms. Sometimes you cannot recognize the same student is very quiet in the classroom, but it's very active in forums. So obviously e-learning doesn't mean that there are no collaboration, no interactions, no discussions, so on. So fortunately, good e-learning system currently support a lot of interactions, group work, collaborative work, and so on. As you saw in this example and others, we now can include Java grader or something like this that you can really exchange your source codes and check whether it's okay or not. Now we are purchasing some software that instructor can see on his screen what each student is doing on his computer and can interfere and can interact with him and so on. So we are increasing this interactivity and joint work. The only solution that we didn't solve until now is how to motivate students not to use mobile phones during lectures. And this is something that's, I don't see much progress in this. We can forbid it, but we don't want to do that. So we just want to make students more motivated to really participate. And that's why this active learning approach is very important. We all have to learn more pedagogy, not only technology as we are currently doing, but how to organize teams of students, project-based work, collaborative work, learning by doing, and such sort of different approaches to learning, not just reading and repeating and answer the questions on tests and so on. So obviously there are a lot of room for further development of e-learning methodologies, technologies, exchange of practices, and that's why we think that such a conference is pretty useful, and I hope that together we can work that this conference grows and also improve the quality of our presented works and so on. So I invite you to join us next year, bring your colleagues, your friends, disseminate information about the conference, because there are a lot of conferences these days in every area, including e-learning, but we want to advocate our conference because we think that we have something to show. And as this is the only conference in Serbia focused only on this, I think that it's good that not only people from Serbia but from the region should participate. We are very happy that now we have for Middle East participants. We hope to have it more, not only from Europe. And I hope that the organizer will do it, more work on that. I want to help everybody who participate in this conference, especially organizers, nice ladies, the chairman of organizing committee. I suggest that next year we all come again here and try to discuss further these interesting topics. Thank you, everybody, and now let's join to a buffet lunch. Thanks.